An ornithologist is someone who studies birds. I've actually never met an ornithologist, but I have a pretty clear picture in my head of what they might be like. Soft-spoken, introverted, and only interesting to other bird lovers. My guest today, Yale University ornithologist Richard Prum, definitely shatters those stereotypes.
Here I was doing the job of science, ducks and anatomy and looking at papers about genetics. And all of a sudden, there we are with these profound political implications of the work.
Welcome to People I Mostly Admire with Steve Levitt.
The topics Richard Prum has tackled are shockingly broad, from explaining the emergence of feathers in dinosaurs, to the evolution of beauty, to the benefits of integrating cultural studies into biology. In each case, his ideas have directly challenged mainstream biology. His theories have won the day on some topics. In other areas, he's still engaged in what is often a heated debate. So as far as I can tell, Richard, you know just about everything there is to know about birds. And I've never actually in my entire life talked to someone who knew anything about birds. So I've got a lifetime's worth of questions, and I'm just going to start bombing them at you.
Go for it.
Well, let's start at the beginning. How did birds even develop feathers in the first place? Obviously, it's an amazing gift to be able to fly, but it doesn't seem like the intermediate steps along the way would be very useful.
Yeah, most people have seen the question of the evolutionary origin of feathers as essentially related to the remarkable capacity of living birds to fly around. That was such a powerful notion that people said, oh, feathers are critical to flight, so they must have evolved for flight. And that led to an unproductive century of noodling about how feathers likely evolved from scales. Feathers grow out of the skin. They have lots of features similar to scales, but in fact, turns out they have a very distinct evolutionary history and developmental origin. So going back to my first ornithology class, I had a lecture on how feathers grow, and the next lecture was how feathers evolved. And the interesting thing about feathers' growth, they are branched like a tree, but they grow from their base like a hair. So imagine a tree where the trunk grows out of the ground last. That's how feathers actually do it. So in the next lecture, I was entertaining the century-old hypothesis that bird feathers evolved from elongate scales that would catch air and allow birds to fly. That idea implies that the top of a scale and the bottom of the scale are like the top and bottom surfaces of a feather. But it turns out that feathers, the way they grow, is that they're tubular. They're, as we say, totally tubular. Yes, that's shameless co-option of surfer slang to talk about how cool feathers are. But it turns out that the bottom surface, the undersurface of the feather, comes from the inside of the tube because it grows out and then unwraps. And that observation led me to think, this idea is a crock. And so we need to do it.
So you were teaching some ornithology class, and one of the topics you taught about was feathers and how they evolved. Now, you hadn't thought about it, but once you did, it didn't seem to make any sense. So you came up with your own theory.
My theory was that down feathers were not derived, but that down feathers might have been closer to the origin of feathers themselves. It was based on the details of how feathers grow today, which we can observe in the lab or in a chicken or in a baby pigeon that's maybe nesting on top of the air conditioning of your apartment. There's a causal information about evolution in development.
So based only on what you knew about modern feathers and the way in which an individual feather grows, you came up with a theory about how feathers evolved back before birds existed, back in the era of dinosaurs. And you wrote this down and you published it. Did anyone believe anything about it?
I wish I could say that last part. It lingered in my ornithology notes as a set of ideas. I really ought to publish that someday. But, life is busy. 3 kids at home, changing diapers, we're trying to get tenure, all sorts of things going on. And then in the late 90s, there were some discoveries of fossil dinosaurs from China that were really revolutionary, and they had fuzzy stuff. People called it dino fuzz. Some people wanted to call it feathers, and it certainly conflicted with the main hypothesis, which is that earlier feathers should be earlier in flight. But these were clearly just fuzzy. They didn't function in flight at all. But my theory was very congruent with that. I actually had a student in my ornithology class, Zhou Zhonghe, who was in Beijing. And as an undergrad, he had worked at the museum where the specimens had been discovered. And of course, these were revolutionary and obviously going to be published in the very top journals in the world. So just to make sure that the story didn't leak out, anybody who knew about this was sworn to secrecy. But he took ornithology with me, and he came up after that lecture and he said, "This is really good. I really think you ought to publish this. Like, you really, really should publish this." And what he knew was that these fossils were out there. He couldn't tell me. But indeed, as soon as they came out, I basically rushed this into publication. So it came out in 99, which was the same year that the very first fuzzy dinos were reported in the journal Nature. So it was timely and turned out to be really well supported. Now by molecular evidence of how cells communicate with each other to generate complicated feathers, and then paleontological evidence that the modern morphology of feathers is restricted to those dinosaurs that are most closely related to living birds.
What I still don't understand is you're coming up with a theory of the evolution of feathers. A requirement at each step is that whatever they're doing along the way is good for the dinosaur. It's actually helping the dinosaur accomplish some task. Could you walk us through what the tubes were doing that was good for the dinosaur along the way that really fortuitously to turn into feathers?
Actually, the theory is entirely wired in a different way than what you outlined. The tradition in evolutionary biology to say the way to understand the origin of innovation is by looking at function and adaptation is actually proven to be really a poor idea. What we needed was something that was independent of those notions to provide the evidence. And that evidence is the structure of how things grow. This area has had lots and lots of interesting and fascinating intellectual contributions, but feathers is certainly one of the biggest ones. So instead of asking what feathers were good for, I asked, what is the simplest feather that could grow? So I came up with a theory that was not about what feathers are good for, but how the modern process of feather growth could have originated. The first feathers were tubes. The second were a tuft. After that came a planar vein that could have been open. And then only later would you have a feather that would catch air and function in flight. In one rather snarky line in some paper I wrote, saying that feathers evolved for flight is the thing that fingers evolved to play the piano. Only the most advanced kind of digit could function in that way. And that's actually supported by lots of evidence now.
I know eventually they're going to be for something very different, but what do you think feathers were doing for the dinosaurs when they were getting started?
Yeah, well, that turns out to be an interesting question that is still rather open-ended. Was it soft? Was it spiky? Was it hard? We don't know. So among the things they could have done would be water repellency or insulation, or they could have looked really cool. It could have been that they were social signals. So all those things are on the table, but we know that flight was basically among the very last things that feathers evolved for.
I have to imagine that the experts in the field, which you're not a paleontologist.
Yeah.
They must have been extremely resistant to your ideas, no?
Yeah. I met somebody about 10 years ago. I think it was a visiting speaker, and he was in my office, and we were chatting about his seminar. And he said, I got to tell you, my first year in graduate school, I went to this meeting, and the first session, you were giving a talk, and I was in the front row, and there was a guy who got up at the end of your talk and started lecturing at you, and you guys started going at it. He said, I thought there was going to be a fight. And he said, wow, this is science. This is the most exciting thing. In any case, yeah, there was some controversy. It had to do also with a simultaneous debate about the origin of birds themselves. And at that point in the late 90s, there were still people who were contending that birds were not dinosaurs and that they came from some vague origin in the early Archosaur, this group that includes dinosaurs and alligators and birds. But in fact, paleontologists, they were mostly people who were studying bones, so they didn't know much about the skin, and that's provided a lot of opportunities for me along the way.
It seems like this idea won the day very quickly for a scientific debate. Is that true? Is it just that the evidence was too overwhelming?
I think it was because also the energy of the opposition collapsed. You couldn't claim that Deinonychus, a raptor dinosaur like the velociraptor that was running around in the kitchen after the kids in Jurassic Park, was unrelated to birds when all of a sudden you found a fossil of something very related that was coated with feathers. That was really it. But also on the science side, we had great molecular developmental biology, really continued this fossil discovery. So yeah, it was rather rapid, probably 5 years.
Now, what's strange about this is, if we said you're not a paleontologist by training, at least when you started, you were a good old-fashioned ornithologist.
I still am. The
kind of guy whose greatest pleasure, it seems, was going to faraway places with binoculars and a notebook observing birds, right?
Yeah, absolutely. That's my roots. I started bird watching at about the age of 10. I got my first pair of glasses. The world came into focus. And within a few short months, I had a life list where I was counting the birds that I'd seen. And there's very few things you can do at the age of 10 that make you think of your whole life. But this is one of them. And so I knew I would have a bird-filled life, but I didn't know what that meant. And even until about the time I got to college, I figured I would be a ranger or like a manager of a forest reserve or something. And it's then when I discovered that there was research and all kinds of opportunities in science, especially evolutionary biology, was the area of science that really reflected what I was interested in. I never considered anything else.
Now, when you were a kid, would your parents drive you to faraway places to watch birds?
Yeah, that got a little tiresome, but I had a lot of friends, garden club ladies. One of my friends in elementary school was a Yale graduate English major hippie who was hanging out and birding, and they took me all around.
Dragging you around as a 12-year-old.
Yeah, so in elementary school, I had a network of at least a dozen adult birding friends. I had good ears, and they had cars, and so it was a really good relationship.
So your first big project was on a bird called a manakin. What makes a manakin especially interesting?
Manakins are South American and Central American birds, so neotropical. And unlike their relatives, they eat fruit. So they're small chickadee-sized or, little sparrow-sized birds, even smaller than most sparrows. And so it turns out that the evolution of fruit diets has some interesting implications for reproduction. If you can feed your young on fruit, then the living is easy. Insects, by contrast, don't want to be eaten. They make themselves prickly and ugly and nasty tasting, hard to find. But fruit is all brightly colored, sitting right there. It wants to be eaten. The fruit is made by the plant so that somebody will come eat it and disperse the seeds. So if the living is easy, you may be able to limit reproduction and parental care at the nest. If you get rid of the dad at the nest, then the mom can raise the babies on fruit on her own. Then suddenly you have a new opportunity. And in this case, what happens is that females choose their mates on the basis of whatever it is they like. And that leads to rapid evolution by mate choice or sexual selection. And so the cool thing about manakins is we got now 50, 55 species in the neotropics who have been eating fruit for millions of years. And dad was released from reproduction or from nest care over 10 million years ago. So since that time, they've just been radiating in this marvelous way. So the males do all these outrageous courtship displays, and the females are the source of selection. And so that led to this whole still ongoing research on the evolution of display behavior in manakins.
So you were young, you were just a kid right after college. Somebody gave you some money to go spend a year in South America looking at these birds? Is that essentially what happened?
Yeah, it was a modest gift from grandma.
Grandma?
Yeah, who wanted to see something happen. And so with that $1,200, $1,300, whatever it was, of course, this was 1982. I went a lot further. I got myself a plane ticket and some camping equipment and went to Suriname, which is in northeastern South America. I didn't make it for a whole year because Suriname had a political revolution and ended up home after 6 months. But it was a transformative experience for me. I had the name of a few people who were in charge of the wildlife and national parks department, and I organized an opportunity to head up to one of their national parks where they had a lot of manakin species. I lived in a kind of bunkhouse with the workers who cleared the trails and did the physical work of keeping this park open. They charged me $1 a day or something like that. So I set up shop. My days were up at dawn, before dawn, out on the trails, bird watching. And I had to bird watch my way through the avifauna until I found the bird I was looking for, which were manakins that were poorly known. I was able to find 2 or 3 species that were pretty well known on even the first day. Within a week, I'd found one species that was unknown outside of the museum. Nothing had been written about it except description of its plumage. Soon after that, I found another. And so I would alternate days getting up, watching individual birds as long as they tolerated me and as long as they kept active. My patience, just willing to sit down with these single birds and see what they were going to do, was really an asset. And ultimately, I saw lots of things that nobody had ever described before. So I knew before I got home that I had some unique contributions, and that was really quite a buzz.
Now, you watched all these birds, but then later in graduate school, you were going to start dissecting these birds too, right? Cutting them open.
Yeah.
What were you looking for inside the birds?
What I was really looking for was an intellectual opportunity to combine the science I was intrigued with the bird watching that I loved. And also I realized that my connection to birds as a bird watcher was not something to be ashamed of. I actually know academics, they don't want people to know they're actually bird watchers. They think of it as degrading the quality of their scientific reputation. But I realized that this was a strength. If I could connect science to birding, then I would have an edge. And not only that, I would enjoy it. The science that I was really interested in was the science of phylogenetics, how we reconstruct the history of relationships among organisms.
So phylogenetics are essentially trying to look at the genes and the structures of different species of animals to try to figure out when they split off from one another and how they're all related.
Yeah. Phylogenetics basically defines a relationship in terms of the history of common ancestry. That result of that is you branch to new different kinds of organisms, you get a tree. And so the effort was to use current available information about biodiversity, their morphology, their anatomy, and now their genetics and genomics, to reconstruct the shape of the tree, the history of their relations. And of course, this is so useful. We're seeing it in the newspapers all the time. Oh, what's the latest strain of COVID? Oh, it has this name and it fits here on the tree. This is how it evolved, right? It's happening constantly. It's now a core phenomenon in science, but into the 80s, it was still a revolutionary idea. So what I really want to do in my dissertation was combine phylogenetics with bird watching. I saw from my time in Suriname that there were opportunities. Every species didn't have just a completely distinct behavior. They shared behaviors. And this pattern of shared behaviors itself had a history. And so what I wanted to do was look at the phylogeny of behavior and how does behavior evolve on a tree. And to do that, I needed to have a decent tree of the relations among mannequins. So in order to do that, I got into anatomy.
So what were you doing to the birds? What were you looking at inside the bird?
I used museum collections and I looked at their syrinx. And the syrinx is the unique organ that birds sing with. And it's located right where the airway, the trachea, branches off to the 2 bronchi going to the lungs. And in that, they've evolved a new vocal organ. This is interesting because we have muscular tongues, right? And you think about a frog ejecting his tongue out to capture a fly. That's the way tongues are in tetrapods. They're all muscular. But somewhere back in bird history, and we don't actually know where, about the time of the origin of birds from dinosaurs, birds evolved a bony tongue. And it turns out the vocal organ that we and also frogs and other vertebrates use, the hyoid apparatus, the larynx, was turned into a tongue for birds. So birds were evolutionarily silenced. They had no sound. So they had to invent a new thing, and they did. And that thing is the syrinx. And of course, the thing they invented turns out to be more amazing than any laryngeal sound, right? They do a lot of stuff with this little, it's about the size of a piece of spaghetti, about 1/3 of an inch long.
And this is made out of bone, or what's it made out of?
It looks like a Y-shaped vacuum cleaner tube. They can be cartilaginous or ossified, and there's little muscles, and they can attach in different places. I'm still fascinated by the syrinx, and actually I could have sailed off and become Dr. Syrinx a long time ago. And maybe I will again someday. But I did a lot of syringeal dissection and description of the syringes of mannequins and other relatives.
We'll be right back with more of my conversation with ornithologist and evolutionary biologist Richard Prum after this short break. Now, what did you find in this research? It set you on a long path, right?
Yeah, certainly. What I first found was that the behaviors that birds were using in their sexual communication had complicated history. I learned how repertoires of behaviors evolved, how innovation in a series of behaviors can happen, how complicated behaviors can be made of the combination of ancestral ones. And this supported one of the fundamental ideas that the science of ethology or animal behavior had been focused on in the early 20th century, which is thinking of behavior just like the organs of the body as having this complicated history of homology and derivation. So all of this is occurring through mate choice. And that led me to become interested specifically in why do female birds select the mates they prefer? What is it about them that they prefer? And how does that give rise to this amazing diversity of plumages, calls, vocalizations, and display behavior?
So we've been talking about it in very sterile scientific language, but you wrote an extremely popular book on the evolution of beauty that I think intentionally tries to move away from the sterile scientific version of it, where the female birds in particular take on a very active role. In your view, these birds are doing something exciting, it seems like.
Well, actually, the language in the evolution of beauty is popular, but the scientific ideas represented are exactly those that I would apply in my own work. There's a new vocabulary, but among those that I think is defensible is actually the use of beauty in science. That birds are beautiful because they're beautiful to themselves. That their subjective, social, and sexual choices are an evolutionary force that drives the origin and maintenance of biodiversity. Even though I'm articulating it in both popular science and scientific papers, that's exactly the scientific idea that I'm proposing.
So the traditional view that people have held through the 20th century is that females choose male mates because whatever dance they're doing provides information about the fitness of potential offspring. That's been the traditional view, and one that you think is ridiculous, right?
That's a good summary, yeah. The idea of sexual selection by mate choice was proposed by Darwin. And at the time, in 1871, many of his most enthusiastic supporters thought it was a disastrous idea.
Everybody knows about natural selection. That's what gets talked about all the time. But when you say sex selection, you're talking about a very different force acting in evolution. Can you explain the difference between those two?
Darwin proposed the idea of sexual selection, which is that unlike the struggle for survival, which gave rise to adaptation by natural selection, there was also competition among mates. And sometimes it's direct competition, like imagine males with antlers battling over opportunities to mate. Or sometimes it's through choice, females selecting and choosing among available competing males for mates. In both those cases, the features like antlers or display behavior don't contribute to survival of the males involved. They may actually get in the way. They may make it harder to survive. So how would they evolve? And Darwin proposed that they evolve by sexual selection. But when Darwin proposed it, the idea that male-male competition structured the sexual world was immediately adopted. This looks just like the Victorian world, right? So that makes sense to us. But the idea that females were choosing, which of course was fundamental to Darwin's ideas, was parodied and rejected.
Why do the females get the choice and not the males?
Well, I should say there are plenty of species in which males make choices, both males and females make choices, or just females only. So we've been talking about female choice, but really it's mate choice broadly. But in Darwin's examples and in many of the most extreme examples we still have, it's female choice that is really a driving force. And the idea that female choice could be a driving force in evolution was both socially and scientifically radical, and people rejected it.
And the females get the choice because they're doing the work of raising the young?
That's my view. But to Victorian critics of Darwin, it was like cognitively impossible. One reviewer said, Darwin is a traitor to his cause because the real value of adaptation was that it explained all of it. And now he's telling us there's something more. And they rejected that. Especially Alfred Russel Wallace was one of his main critics. And Wallace basically posed, even if mate choice happens, it can only happen if the thing that's being chosen is actually better. Lives longer, has heritable benefits to your babies, has better worms and better territory for your young. And so that basically said sexual selection is a kind of adaptive natural selection. So you have these choices. Either sexual selection doesn't exist or is a kind of natural selection. In my view, it really is the authentically Darwinian one, which is that sexual selection is a distinct evolutionary force and that it has all sorts of historical and evolutionary consequences and that adaptation is only one of them.
It seems at some level incredibly obvious that if females were getting to choose and there was something about males that the females liked, then those males' genes would easily go to the next generation. Now, I know it's more complicated than that because in the simplest models, it washes out, right? You need this correlation to go on. Can you talk about this correlation and where that comes from?
One way to think about it is comparing the value of beauty to the value of money. Where does the value of money come from? Well, in the old days, it came from the gold standard. Every dollar stood in lieu of a tiny piece of the pile of gold in Fort Knox. And so that gave people faith that this stuff had value. The value in that case is extrinsic to the money. But for the last 60 years or so, we've abandoned the gold standard. The value of the dollar is not linked to the gold. And where does the value come from? Currencies only have value because we invest trust as a group in them. The Wallaceans and the good gene folks that think that mate choice is an adaptive force, always, are basically on the gold standard. They say that the value of beauty is not the beauty, it's actually in the gold. The gold is the good genes, the better worms, protection from sexually transmitted diseases, etc. There's an objective benefit. The opposite is that it's just a result of subjective value, the norm created by the population itself. And of course, in this era of Bitcoin, Dogecoin, and GameStop, it's not hard to imagine that the value of a commodity can be unrelated to the actual value in the material world of the product or whatever it is they're trying to do. So my colleagues are on the gold standard, and I am claiming, you know what, guys, there's no gold. Or more scientifically importantly, the burden of proof is on those who think that there's a pot of gold at the end of the rainbow.
So if a signal of a display that a male is making indeed is a sign that they're really healthy or their offspring will be healthy, it's really easy to understand why evolution would favor that. So let me just make sure people understand your version. The females are making choices, and maybe sometimes they're making choices about which males based on true signals of whether the offspring will live or not. But sometimes, for whatever reason, the females of a species like something about the males. There's something arbitrary. So it could be the way they look. Maybe these males do kind things to females and females are more interested in reproduction with males that are kind. Really, it's just arbitrary. But I think what's strange but fascinating about what you're talking about is when it starts, it can be anything, but this positive feedback loop emerges. Because
Absolutely.
Let's just say that a bunch of females within a species, for completely arbitrary reasons, are attracted to long tails. It's got nothing to do with flight, nothing to do with anything. And so then they pick a bunch of males that have long tails. And I think the key to your story is that now in the next generation, you've got both a bunch of offspring with long tails, but also they've got the genes for liking long tails tied up with the having the long tails. And this ends up becoming some positive feedback loop where over time, it gets stronger and stronger.
That's exactly correct. Once you have a preference, even if it's for an adaptive purpose initially, like, oh, they like large mates because large mates have great diets or good territories. But once you have a preference, that preference itself has a power, which is that it's going to go out in the world and to become genetically associated with the thing that it prefers. When preferences for long tails or blue heads become associated with genes for long tails and blue heads, then when choosers select on what they like, they're also indirectly selecting on those traits for preference itself. There's a self-organizing engine for the origin of a selective force. And that selective force can be completely arbitrary from natural selection. The math has supported that for a very long time. But evolutionary biologists are still resistant to it, mostly because many of them grew up reading Richard Dawkins as a teenager, and they feel like their mission in their intellectual life is to rediscover that buzz. And this is the way to do it in birds.
So Richard Dawkins is an extremely famous evolutionary biologist who wrote The Selfish Gene, who I think would represent the hardcore adaptation team, the team that you, Richard, are not on.
Correct.
The obvious example is something like the peacock's tail. The peacock's tail doesn't seem to be doing the male peacock any good. And in your view, it was a matter of taste and it got out of control and fashion went crazy. So let me try to channel my inner Richard Dawkins and imagine what he might say. No, the peacock's tail, in order to walk around with such an enormously ineffective and life-worsening tail, it's a way of the male peacock showing how actually amazing he is that he can get by in life even with this tail.
What really has happened scientifically is that this idea has become so popular. The idea of mate choice as adaptive benefit, either through good genes, this male has survived with the tail because he's got better genes than the other male. And so your kids are going to be better quality because you mated with this beautiful male. Or direct benefits, which was more like, the guy has a great territory with a lot of worms for my kids, so they're going to grow up faster and be healthier. These are adaptive mate choice hypotheses. So people look for evidence of them, and when they find them, they publish, they get tenure, they become famous, they get more grants. If they don't find them, they conclude that they have failed to do science because that's what science requires. This is the equivalent of saying every piece of beauty in the world, every kind of peacock's tail is like a rainbow leading to a pot of gold. And our job is to find the gold. That gold is the extrinsic benefit of the beauty. This is where my gambit, my attempt to overturn this view is to say the burden of proof is on the adaptation, on the idea that beauty is somehow correlated with this extrinsic benefit. And so if you haven't found the worms, if you haven't found the good genes, that means that beauty is arbitrary. But the current standard is that this little piece of math that supports this is considered so exotic and nonsensical that you need overwhelming and abundant proof. But of course, you can't prove the null hypothesis, which is perfect for this adaptationist view.
In general, I'm sure evolutionary biologists are not dumb people, and you're clearly not a dumb person either. I got to believe that the listeners who are outside of science, who are hearing what you're saying, are a little bit shocked because that's not how we think science works, right? We think that smart people develop hypotheses, they look at evidence, they try to sort things out. How can reasonable people looking at the same set of evidence come to such radically different conclusions? And one view is that it's blindness, somehow that being brought up within a particular discipline blinds you to common sense, which I think is not impossible. Another possibility, I guess, is just that the data aren't very good, right? So that if you have strong priors in one way or the other, the data aren't good enough to push you in the opposite direction. And your position is really a difficult one scientifically because you're trying to say, look, these things are evolving not because they're adaptive, but just because they're quirks of fashion that happen. The scientific process is completely rigged in favor of the status quo because they've set you to an impossible task of ruling out every possible story about adaptation when the dimensionality of those adaptation stories is essentially infinite.
So first I'd say, surprise, science is done by people. Humans, social behavior, all sorts of things at play. So those priors are actually really strong, but those come from social environments in which people inherit, learn, adopt their priors, right? And those are labs and meetings and journals where like-minded people agree on what the important questions are. And of course, intellectual change is hard. And so that's what I'm up against. This is not a tough problem. It doesn't have to do with the quality of evidence. It was clear to Darwin. Darwin described this very well in 1871 in the same exact language that people now see as brilliantly prescient. In his ignorance of genetics, how could he have described natural selection so well? Well, he did the same thing with sexual selection, but people don't want to hear it. Why? Because reviewers of The Descent of Man, his book on sexual selection in 1871, see the idea of arbitrary evolution of beauty as a traitor to Darwin's true cause, which was that adaptation by natural selection is a strong force that can describe everything that's important about nature. Darwin saw that as false, and so it's not a hard sell. This is false. And why is that still a problem? It's still a problem because of culture and sociology of science, and it's faith-based as well. The fact is, it's a broader problem, which is the idea of reduction. This is an argument for a greater complexity. You've probably heard of the idea of the blind watchmaker, right? This is a title of one of Dawkins' books. It's the idea that the beauty of adaptation by natural selection is that there are no agents involved. It's just like going to take place. But the idea of the blind watchmaker as a description of all of biology denies the fact that nature evolved eyes, that animals have eyes. And those eyes are connected to brains, to cognitive complexity and social opportunities. Perception, cognitive evaluation, and choice lead to emergent new phenomena, which are preferences for traits that themselves become a gatekeeper on who is going to leave their genes into the next generation.
So if I understand what you're saying, females get to dictate very much about what males of the future will look like. And that seems like a feminist, female-forward kind of view of the world. But there are examples where, at least from a human perspective, the females of some bird species really have it bad. Do I dare ask you about ducks?
Yeah, sure. Well, my work on duck sex started well into my interest in aesthetic evolution. A postdoc came to my lab, Patricia Brennan, now a professor at Mount Holyoke College. And Patty wanted to work on the evolution of duck genitalia. And I thought, well, I've never worked on that end of the bird before. I'm sure I'll learn a lot. What I learned in my collaboration with Patty just transformed my ideas about bird biology and really about science. One of the things that's worrisome or problematic about duck sex is that ducks still have a penis. And I say still have because the penis evolved in the common ancestor of land vertebrates, and that includes reptiles and mammals and birds. And so the penis of ducks is actually shared from a common ancestor with the mammalian penis, the human penis.
So you're saying most birds have lost penises over time?
Most birds have lost the penis, which means that copulation or sperm transfer lacks intromission or entry. And so how does that work? Well, scientists for a long time have colorfully described this as a cloacal kiss. So it's just the apposition of orifices where the sperm is released by the male and taken up by the female. That's fascinating because that means both that their sperm is robust enough to be exposed in this way and still make it, but it's also related to the question of why most birds don't have penises at all. In my work, we've been emphasizing how female choice can transform maleness in ways that further female sexual autonomy. That is, females can prefer some feature because it gives them more freedom as a group, and that can evolve. And one of the ways this might happen is that females might prefer to mate with males that don't have penises, because that means that females have to be active in the acquisition of sperm, which means that they have, through their own choices, figured out an irreversible way in which rape can no longer occur. But ducks are an early branch in the tree of living birds that still retain this penis.
Okay.
And the penis of ducks is really different. It's stored inside, outside in. Most of the time, erection is lymphatic instead of blood vascular. And erection is also almost instantaneous. So a duck will have a penis that's, 8 to 12 inches long. And that penis becomes erect in about a third of a second, which we described as explosive erection in our paper, describing this common barnyard phenomenon for the very first time with high-speed video. So this research certainly got lots of play, and we ended up in trouble with Fox News and senators from Oklahoma that called us to the carpet for wasting America's tax dollars on our grants working on duck genitalia. But what Patty discovered was that a phenomenon that had been known a long time, which was sexual violence in ducks, which is really problematic, leads to a very fascinating outcome. But this is really the equivalent of rape in ducks. So what happens in many puddle ducks, that is ducks that have lots of resources that are highly concentrated and breed together, at the same time that the male and the female pair are composing a nest and laying eggs, other unpaired males will attempt to forcibly copulate with that female. So what Patty discovered was that female ducks in species with lots of forced copulation have evolved vaginal complexity that excludes the penis from entering the female reproductive tract. It's a convoluted corkscrew that goes in the opposite. Oh, I forgot to say the duck penis is corkscrew shaped. It's a counterclockwise spiral that exclude the penis during forced copulation. And so what this means is that females have evolved features that allow them to prevent fertilization by forced copulation, even though they suffer the direct harm of sexual violence, which is both physical violence and, in some cases, death. So what we discovered is that freedom of choice matters to animals, and there are evolutionary consequences to its infringement by social sexual violence. Freedom of choice is not just a social political concept invented by suffragettes and feminists in the 19th and early 20th century, but is actually a phenomenon that evolves in nature. And this experience was profound for me because here I was doing the job of science, ducks and anatomy and looking at papers about genetics. And all of a sudden, there we are with this sort of profound political implications of the work.
So just to make sure I understand, when you say freedom of choice, what you're saying is that the female ducks don't like the forced copulation. And while they can't stop the forced copulation, they've evolved vaginas that essentially punish the ducks who are doing forced copulation by not leading to reproduction. Is there evidence? Do we have numbers?
Absolutely. In species where 40-50% of the copulations are actually forced in observation, over a pond, only 2 to 5% of the eggs in the nest are fathered by some male other than the social partner. That means they have a 95% success rate at excluding sperm from fertilizing their eggs. That's like an FDA approvable birth control device that they can behaviorally deploy when they need it. How would this even evolve? And in fact, Patty and I had great difficulty even publishing these papers because they were so contrary to the dominant concept of what sexual conflict was about. And now we've actually gone through and we have population genetic theory published with my student Sam Snow and other collaborators, where we demonstrate mathematically that this can happen. When the female mates with the guy with the green head that she loves and the quack, quack, quack that she's just delighted by, then her male offspring will inherit those features that other females have co-evolved to prefer, right? But when the female is forcibly fertilized by sexual violence, then her male offspring will either inherit a random set of traits, displays, or ones that she specifically rejected. And in both cases, that means that her male offspring are less likely to be preferred by other female ducks. And so it turns out that there is a social sexual advantage in the pool of female ducks to have had the opportunity to choose your mate, because other females will agree when they have an opportunity to choose their mate. So this is basically sisters are doing it for themselves, right? They are gathering together as a social force to advance their own aesthetic purposes. After the book came out, I had a piece in the New Yorker called Duck Sex and the Patriarchy. What's interesting about this is that a lot of people say, oh, well, this is an arms race. Duck penises get more complicated. Vaginal morphologies get more complicated. That selects for more complicated duck penises, which select more complicated vaginal morphologies, et cetera, et cetera. And indeed, that's why you can have ducks with penises that are longer than the duck. Literally, there are species like that. But one of the ways in which this is not an arms race is that females are evolving to reinforce freedom of choice. They are not gaining control over males. And so you have male efforts to actually gain control, forced copulation, forced fertilization, and then female are just saying, oh no, it's about our choices. And one of the things that's in common with 21st century culture is that people respond to feminism as an assertion of power or control over maleness rather than as an argument in favor of freedom of choice. So I think these same dynamics are informative to other kinds of sexual conflicts, even in ourselves.
You're listening to People I Mostly Admire with Steve Levitt and his conversation with ornithologist and evolutionary biologist Richard Prum. After this short break, they'll return to talk about how Richard is turning mainstream biology on its head.
Richard Prum often finds himself at odds with mainstream biology, but maybe never more so than with his most recent book. I want to dive into that now. I want to end talking about your latest work because I think even our talk about duck sex, nothing that we've talked about today will prepare listeners for what your latest foray is into applying a new tool set to the set of questions that you're interested in. So your latest book, which is entitled Performance All the Way Down, is an attempt to incorporate queer feminist theory into biology. And before we even get into the actual ideas you write about, I'd love to hear how you got started down that path. Was it the duck sex that got you going on this?
Yeah, very much so. And in the last section of Evolution of Beauty got into the evolution of human sexual behavior, which of course, whole long history of adaptationist arguments applied there. And I was always applying aesthetic arguments and arguments about sexual autonomy in human evolution. After writing The Evolution of Beauty, I stated in there that our discovery of the importance of sexual autonomy, of freedom of choice, was a feminist discovery in science. I wrote that as a sort of gut truth, but in fact, I didn't know how to defend it. It wasn't feminist in the sense that we started with a bunch of ideas and said, okay, let's make a science that has these social and cultural properties. In science, we had discovered that the analysis of sexual conflict that feminists had developed in human context applied in an important way to the biology of non-humans. And so what can that mean, feminist science? And of course, there is an entire area in academia that is interested in feminist science studies, analyses of the history of science, the philosophy of science, and the sociology of science from this perspective.
My own experience with the humanities and with cultural studies especially is that the specialized vocabulary and the form of argumentation, they're so foreign to me that I have a difficult time understanding the points that an author is making. Was that not so true for you as you got into this literature?
I definitely experienced that. I still can experience that. I also read a lot of stuff that was gobbledygook that I never got anything out of. But what was intriguing is that there were certain authors that started to land. I started to appreciate what they were saying. And in particular, Judith Butler, who is a feminist philosopher at Berkeley, who has worked for decades on the performativity of gender and gender as a performance. Some of these classic works were notably difficult and not written for a general audience. And yet, sitting with them, reading them, they got under my skin. And I realized that, they're kind of onto something, but they haven't yet understood the biology. And so originally I started pursuing the idea of performativity or performance is a kind of common language where science and queer theory or feminist theory or culture studies can communicate. But then I got much further.
So knowing that I, and I suspect many of my listeners, we come from a place of almost complete ignorance on these issues, can you explain the big idea or ideas in your new book in a simple enough way that you think I'll be able to understand it?
So one of them that I think is very interesting is, we used to thinking of the genome as the blueprint of the organism. And this, I found out, was proposed for the first time in the 50s, so really early on. And so from that perspective, we look at the blueprint, then the body is kind of a material representation of some prior plan or truth, some essence that's in the genome, right? And that's kind of linguistic analogy. But if we look at those linguistic analogies, and we go, in this case, to linguistic philosophy, that's a description of a representational language. Language or communication as a means of representing the world. My hat is on the table is a sentence that attempts to describe a truth. But philosophers of language, in particular J.L. Austin in the 60s, contrasted representational language with what he called performative language. That is language that performs an action in the utterance, in the communication. So I can say, I bet you $100 the Sox are going to win tonight. And that is a social event. That is a doing in communication, not representing the world, but doing in the world. And the idea of performative, the word performative, comes from the idea that communication can perform actions. Now, let's go back to genetics. So the idea there is like, okay, what is the relationship between gene expression and the material body? For 60 years, we're pursuing it as representational. We think that genes are selfish and that explains everything. We've avoided the obvious fact that genes perform action in the world, that gene expression is an action. Now, there is no place anywhere in academics where the idea of performativity has had more impact than in this body of what we could refer to as queer theory. And so what I've done in the book is take a few leading voices in queer performative theory and apply them to the material body and to development and evolution of the body. I could have written the book about feathers or eyeballs or limbs or flowers, but I just thought that genitalia were a lot more central to the argument. And so it's really a book about the material development of the human sexual body. And what I argue is that biology needs queer theory to get the body right, that we're failing, that we have failed, and that this is fundamentally obvious at many levels of biology, but it has profound implications for how we do science and how we teach about science, and also for the relationship between science, in particular, concepts of sex, and the culture.
Can you give me a really specific example of how you would do or teach science differently from a performative lens as opposed to a typical scientific lens?
Sure, I can do this because I just did. I teach, among other things, introductory ecology and evolutionary biology at Yale. And so I gave a lecture on this a couple months ago in my intro bio class to 200 first years. So, for example, remember I was talking about how the penis of ducks is homologous with the penis of humans, that it evolved in this first four-limbed ancestor that came onto land. In humans, the development of the penis is associated with the presence of a Y chromosome in the presence of a single X chromosome. In ducks, it's the opposite way. Female ducks are the ones with the different chromosome. And in mammals, it's the male that has the different chromosome. But if you go to crocodiles and many lizards and turtles, you find out that sex develops in response to temperature. If you're warmer or cooler, you end up male or female, depending on the species. So what could essentially be true about the fertilized egg, its maleness, say, or its femaleness, that could be alternatively determined by having a distinct chromosome, lacking a distinct chromosome, or the temperature? And the answer is nothing. So what this does is undermine all essentialisms in our thinking about sex. Sex is a performance. It's a becoming. There is no essence. Even in the genes, even in the chromosomes, at every level, it is a body achieving some kind of reproductive and sexual capacity.
Now, I would expect that scientists would absolutely hate this research. And honestly, I'd expect the queer feminists to probably hate it just as much. What has the actual reaction been to your book?
You don't write a book called Performance All the Way Down without going all the way down. Right? So among the intellectual challenges of the book is that I'm trying to reach all these audiences. I'm trying to reach molecular developmental biologists. I'm trying to reach queer feminist theorists. And I'm trying to reach interested queer students. I'm trying to reach their parents who want to understand their kids better. Originally, I thought I could write a small book, like a little manifesto that you could stick in your back pocket. I wanted a book so small that you could steal it off of a table in a common room in your dorm, because you might not want other people to know that you were interested in the topic of the book, right? But alas, that's hard. You can't talk about sex quickly. So I have found that people say that it's a tough read. I've gotten a lot of really positive feedback, mostly from the science studies, philosophy, and feminist side. Biologists are just unused to reading books. I remain optimistic. I think the science is really solid. Science is going to change. It has to change because actually our current view of the blueprint and our denial of the agency of cells are just too weak. They're just failing as science. Systems biology is an area that's very much attempting to address the same kind of faults in experimental genetics that I address in the book. But they don't have any kind of intellectual core except for like a commitment to big data and crunching numbers. But this is really a reason why to think about tissues, cells, organs, and history development itself as having an input in ways that are larger than genes in biology.
So you think the future of biology is a movement towards complexity, it sounds like.
Absolutely. I mean, biologists have to wake up and realize that the thing they've been trying to reduce, to explain away, is the whole point of science. That in fact, we should be celebrating the richness of the complexity of the task ahead of us, which includes culture, includes environment, includes organs, and all the complexity of cell communication that are eliminated from proposals like the selfish gene.
So it sounds like you're saying if you're a young person and you're creative, biology is a great place to be right now.
Absolutely. I started birdwatching at 10, and I really never considered any other thing to organize my life around. And that means all these acts, including writing about queer theory, have been just related to who I am fundamentally as a person. And that has just been such a gift. And it's obviously a privilege. I've always felt like I belonged in the room and that what I was contributing was worthwhile. What I really aspire for in performance all the way down is that queer kids will come into the sciences and have that same experience that I did by pursuing topics that are important in developmental genetics, evolutionary biology, and biomedicine that are related to who they are. Sciences need queer theory and queer scientists to make progress. And that, I think, would be a great outcome.
One thing I really admire about Richard Prum is that over and over, he's gone out and learned a new set of tools that allow him to tackle new problems. He started as a birdwatcher, but then he became an anatomist, a paleontologist, and even a queer feminist theorist. We didn't have time to talk about it, but he's also contributed to the physics of how color is produced. A few times in my own academic career, I tried to become expert in subjects outside economics. I gave up every time. The barriers were just too great for me. I do believe, though, that in the future, scientific discoveries will increasingly come at the intersections of traditional fields. So I'm glad that there are people like Richard Prum who have more talent and perseverance than I ever did. This is the time in the show where I welcome my producer, Morgan, on. Morgan, how are you doing today?
Good, thanks. How are you, Steve?
I'm doing great.
So we had a listener named Bob write in, and he had a question about dynamic pricing. And he was thinking about dynamic pricing because Walmart recently announced that they're going to expand the use of digital price tags. And a digital price tag is basically, instead of a sticker on a shelf giving you the price of a product, there will be a little screen, and that screen will be able to update with new prices. So a price could change for a product throughout the course of a day. So Bob wanted to know what you thought of dynamic pricing.
Well, the short answer is that dynamic pricing is efficient in the way that economists use the word efficient. But I spent an entire lecture with my undergraduates trying to explain what efficient means. So rather than go into some long, dry explanation, how about we talk about a couple examples instead? And I think a great example is Uber or Lyft versus traditional taxis. Taxis tend to have fixed rates. There's some changes to taxi prices. Maybe they're higher during certain hours of the day, but mostly they're constant. Uber and Lyft change their prices minute by minute. That's the epitome of dynamic pricing. Say it's pouring rain or there's a sporting event that just ended. The prices at Uber and Lyft, they'll go through the roof as the companies try to equilibrate supply and demand. Higher prices are enticing drivers to come to this area, and that means there are more rides for the people who are there. And because the prices are so high, a lot of people aren't willing to pay them, and that's how they set supply equal to demand. Let's imagine instead of Uber and Lyft existing, it's just taxis. Then when the sporting event lets out, well, a few lucky people will get a cheap taxi that will take them home, and the rest of the people are left waiting or trying to find some other way home. And that is highly inefficient. And you know it's inefficient because there are consumers standing around saying, if only the prices for taxis were higher, there'd be a taxi there for me to take. And that's a sign that the prices are too low, that dynamic pricing would have helped in that situation.
If listeners want to hear more about the pricing structure of Uber and Lyft, they should listen to our past episode with your good friend, the economist John List, who used to be the chief economist at Uber and Lyft. He's now the chief economist at Walmart, which sounds like it's getting into the dynamic pricing realm. Do you think that's a coincidence, Steve?
Probably not. Any good economist who went to a big firm would talk to them about the possibilities of dynamic pricing.
So it sounds like you and maybe most economists like dynamic pricing. Are there situations where it doesn't work?
Well, it's almost always good for the sellers, the ones who are picking the prices, but there are certainly cases where overall it's bad for consumers. And let me just give you an example. The most extreme case, it's just a made-up one, not realistic, but let's just imagine a setting where the company selling a product, they can change the prices at will, and they know so much about you that they know exactly how much you're willing to pay for something. Let's say there's a concert, and they know you, Morgan, they know you love this artist, and you're willing to pay, say, $110 for a concert ticket. Well, they're going to charge you $109. You're going to get all of the surplus, charge you just enough below what you're willing to pay that you go ahead and pay the price. But let's say I don't want to go to the concert nearly as much as you do, so I'm only willing to pay, say, $75. So they'll charge me $74 to see the exact same concert from a very similar seat because they know I'm willing to pay less. That's a case that's not just dynamic pricing. That's a combination of what we call dynamic pricing and price discrimination, where you charge different people different prices for the same good. And that is almost always bad for consumers.
It sounds like over the next few years, Walmart's really going to invest heavily in dynamic pricing. And in general, as things like digital price tags become readily available, that more companies might invest in dynamic pricing. Do you think that's good or bad?
Well, I think it's good for Walmart. It's good for the sellers. I honestly don't think it'll be very good for consumers. If you talk to consumers, they have an intuition that when prices are moving around for reasons they don't understand, it's probably not good for them. And they don't know exactly why, but I think their intuition is pretty solid. That in general, the reason they'll be paying higher prices is that Walmart has figured out that they're willing to pay higher prices. Obviously, it's complicated. If people become suspicious of Walmart's dynamic pricing, then they're not going to shop at Walmart anymore. It's a dance between consumers and sellers. I know Wendy's talked about having dynamic pricing, and consumers flipped out.
Yeah, I guess if companies are investing in something, it's usually because they think it's going to make them more money.
Spoken like a true economist. Morgan, you are really coming along.
Thank you. If you have a question for us, our email is pima@freakonomics.com. That's PIMA@freakonomics.com. If you have a follow-up question for Richard Prum, we can send that to him and maybe answer it in a future listener question segment. We read every email that's sent, and we look forward to reading yours.
Next week, as part of my favorite episode series, we're replaying my conversation with trivia superstar Victoria Gross. It has been an incredible year for her. She won the 2024 Jeopardy Invitational Tournament, the 2024 Jeopardy Masters Tournament, and the World Quizzing Championship. And in 2 weeks, we have a very, very special brand new episode with Richard Dawkins. He's the author of The Selfish Gene and The God Delusion, as well as many other influential books. His name has come up over and over on this podcast, including in today's episode. He's someone I've long wanted to meet, and in 2 weeks, it finally happens.
People I Mostly Admire is part of the Freakonomics Radio Network, which also includes Freakonomics Radio, No Stupid Questions, and The Economics of Everyday Things. All our shows are produced by Stitcher and Renbud Radio. This episode was produced by Morgan Levy, with help from Lyric Bowditch and mixed by Jasmine Klinger. We had research assistance from Daniel Moritz Rabson. Our theme music was composed by Luis Guerra. We can be reached at pima@freakonomics.com. That's PIMA@freakonomics.com. Thanks for listening.
If you see a rainbow and suddenly a leprechaun appears and says, hey, there's a pot of gold, the burden of proof is on the leprechaun, right?
The Freakonomics Radio Network, the hidden side of everything.
Stitcher.